Good morning or afternoon, depending on where you're joining us from. I'm Dane Christensen, Digital Marketing Manager at GridGain Systems. I want to thank you all for taking the time to join us today for our webinar titled Enabling Converged Real-Time Analytics. Our presenters today are John Webster, a Senior Partner at the Evaluator Group and author of the book Inescapable Data, Harnessing the Power of Convergence, and Nikita Ivanov, founder and CTO of GridGain, and a frequent speaker and blogger on the topics of in-memory computing and fast data. But before we get into John and Nikita's presentations, I have just a few quick administrative points to make. John and Nikita will be speaking for about 40 minutes, after which we'll have about 15 minutes for a Q&A. You'll notice that just above the presentation screen is a questions button. Click there to ask a question at any point during the presentation. John or Nikita will respond to your questions during the Q&A segment. Now, we may not have time to get to all of the questions during this event, but we'll definitely answer all of them afterwards, so please take advantage of this opportunity to ask questions from these leading experts in the field. Also, I wanted to make you aware that we've included today's presentation slides in PDF format, as well as a technical insights paper on the same subject written by John Webster in the attachments area. So you can download those for future reference. And one final item, I wanted to make you aware of the ratings button where you can provide feedback on the presentation that will help us to do a better job on the future webinars. And you can see that button right there at the top of the screen as well. So with that, we're ready to turn the floor over to John Webster. John?
Yes, thank you, Dane, and good morning, good afternoon, depending on where you are. As Dane said, my name is John Webster. I am a Senior Partner with Evaluator Group. Evaluator Group specializes in data storage and information management. And recently, as a research project or research area, I've been looking into the progression of the use of in-memory technologies to do analytics, which has brought me to an understanding of GridGain's product and technology, and the technology of using memory as a persistent data store in support of analytic processes. But we'll get into that in a minute. So what we're going to look at here today, here's the agenda slide. I'm going to take you back to the year 2004 to begin with, when a friend of mine called me up and said, geez, John, I need help writing a book. Dane mentioned that I'm author of Inescapable Data. Actually, I'm a co-author of a book called Inescapable Data, Harnessing the Power of Convergence. And my friend Chris Stakutis called and said, I'm trying to figure out if people are seeing what I and some other people in the industry are seeing. We're seeing people using mobile devices like BlackBerries, and the smartphone had just started to emerge. We're seeing the use of different types of sensors. The sensors are becoming more intelligent, and you can make them wireless. We're seeing all kinds of data emerge on the web that people could potentially use. And so I'm wondering if, we thought about converging some of this information in real time, or this data in real time, what kinds of new information sources could we produce? And so that's what we really mean by, or what I'm talking about here, by the real-time data convergence. In other words, it's taking data from different sources and converging it in real time to produce new types of information. But at the time we started writing this, my first reaction was, geez, I don't think really we have the systems to do that. And so I'll talk about that as well. And what we did actually was we interviewed 50 people in business from different industry segments to find out what they were thinking. and what they were running up against if they were trying to pursue some of the visions that we were talking about as well. So I'll talk about a little bit on what was missing in 2004 that is available now. And I think really what is available now is the ability to combine distributed computing and advanced memory technology. So we'll talk a little bit about the confluence of distributed computing and advanced memory technologies as an enabler for doing this real-time data convergence and analytics. And then I'll pass it over to Nikita Ivanov to talk about GridGain's in-memory data fabric as an example of the technology that I'm talking about here. And we'll wind up, before we go to Q&A, with a discussion of some real-time data convergence applications that I am seeing and Nikita is seeing as well. So to get started, let me just review a little bit about what we did with the book. What we were trying, as I said, to do was see if we could conceive of analytic-based applications that were based on the convergence of multiple data sources. And as I mentioned, we interviewed 50 CEOs, CIOs, and technologists from a number of different vertical industry segments, and these included healthcare, retail, finance, media and entertainment, even agriculture, sports. I mean, it was just, we tried to cover as many segments as we could, really, with people that we could find. And what we were looking for were people who may have heard of, you know, the kinds of technologies that were out there. I mean, at the time there was some visionary thinking about using mobile devices as data collectors. And there was also, you know, a lot of talk about connecting electronic things to the internet. I don't know if you remember, there was talk of the internet toaster. So the concept was that you could take virtually any electronic device, give it an IP address, connect it to the internet, write some Java code or some XML code, and it could communicate its state, if you will, over the internet. And so you had people like Scott McNeely at Sun Microsystems talking about, you know, putting intelligent little chips into paint and creating smart paint, and somehow connecting those to the internet or to some kind of a network. And so there was, you know, conceptual thinking around being able to converge data using, you know, these multiple data sources. Then the question became, okay, so if you could do that, and these devices could be pervasive, they could be anywhere, you know, what kinds of new information could you produce if you did that? And one of the things we were trying to figure out is whether or not, you know, some other business industry leaders were sort of thinking or starting to conceive of the same thing. And I have to say that at the onset of this project, I was very skeptical. You know, to me, it was kind of, yeah, just, Chris, this is a great vision, but I'm not sure we're going to find too many people out there that, you know, really thinking this way. I mean, I was thinking in terms of data warehousing systems that were built around transactional structured data, you know, reports being made available to business decision makers, you know, that had to happen days or weeks after data creation. I was not aware of abilities to converge, let's say, unstructured and structured data into the same system and run analytics against it, or, you know, data warehousing processes. And let alone in real time. You know, that was just, I mean, that just seemed to be sort of over the top. But, you know, I went along with the project anyway, and so we went out and we started to interview, and I was just absolutely astounded at the number of people, honestly, that had, you know, some real honest to God practical thinking around trying to do this. And I'll give you a couple examples. We went to, I live in the Boston area, so does Chris, and we went down to one of the major teaching hospitals in downtown Boston. And we talked to the CEO. We described to him our thinking and, what we were trying to research and what we were going to be writing about. And he got very excited. And as a matter of fact, a lot of the people we talked to had a lot of passion around this when we described what it is that we were looking for and, the project that we were up to. And so what he had envisioned was what he thought of as a very simple way to start leveraging some of the things that he was hearing about. He'd already heard about RFID. And so what he was thinking about doing was taking RFID tags and attaching them to pill vials, such that when a drug was taken into a patient's room, as in, it walks in on a drug cart where there are lots of other drugs on the cart. If a patient, patient in the room the drug cart comes into has sensitivity to one of the drugs on the cart, as in it could be an allergic and maybe even fatal reaction, an alarm would go off at a nursing station saying, we have a patient at risk here simply because the drug that this patient is sensitive to is in the same room. And so it was an alarm to essentially tell somebody at a nursing station to say, just absolutely be aware that this has happened, and make sure that the patient isn't accidentally given this drug. To him, a very simple sort of way of getting into the use of some of these pervasive data kinds of technologies. He had other ways that he wanted to use some of these things, but this is his way of sort of getting started. And what he was trying to do was get his systems people to figure out a way to do it. And honestly, they weren't coming up with it. Because what he was trying to do was take RFID data streams in real time and converge it with patient data or a patient database. And they just didn't know how to do that at the time. So that was one example. Another example, we went and talked to the CEO of a company that was actually in the business of manufacturing sensors for industry. And they had, for example, a line of chemical detection sensors. And so one of their lines of business was selling these sensors to chemical manufacturing plants that they would use to determine whether or not a chemical leak had occurred. And so what he wanted to do was, the first thing that he wanted to do was make these chemical sensors wireless, right? Because one of the big challenges with, deploying these things in a chemical factory was actually getting the wire to them. So the first thing he wanted to do was make them wireless so he could put them basically anywhere. And then he wanted to, attach them wirelessly to a network. And that data would then be fed back into a system. And the system would potentially be able to determine a number of things. Because of the spatial arrangement of the sensors, you could sort of pinpoint where a chemical leak had occurred. And you could see the progression. If you were to project it on a map, for example, you could project the progression of the chemical leak, and you could determine really where the leak was emanating from in real time. And given some more intelligence, you might even be able to figure out exactly what chemical is leaking and come up with a remediation plan, again, in real time. But again, his comment to us was, we're not sure we can figure out how to do this for sure. Our customers can't figure out how to do this yet either. So what we kept finding when we were talking to these people is that they had lots of visions of using real-time data to do some sort of basic real-time thinking in a way. They just didn't have the systems to be able to deliver it. So ultimately, what is the point I'm trying to make here? Oops, sorry, I'm getting a little mixed up with my slides here. What I'm really trying to say here at the outset is that I think the need for this kind of technology, the kind of technology that we're about to talk about, has actually existed for years. It's not a question of somebody going out and creating a technology and then trying to find applications for it. I think that the need for, let's say, the convergence of distributed computing and in-memory, or the advances of memory, has existed for some time now. And to do the kinds of information producing that I'm talking about here to business decision makers, to the public sector, and even consumers. And so we'll talk about some examples of that, I think, coming up. But let me talk now about what's, I think, enabling, what will enable CEOs to sort of imagine or bring into reality the kinds of visions that they've had for years. And I see it as the confluence of two major computing trajectories. And they've been going on for, some period of time. If you go back to sort of the beginning of computing, if you will, we've had computers that use memory. So continued improvements in memory technology that actually began with the first digital computers, and we've just pushed that memory technology forward and forward until the point where we've got very large, scalable ways, or let's say ways to use memory technology in very scalable ways, and actually create a persistence layer for data storage in memory. So that's one. The other is the advancement of MPP computing that began back in the early 1980s. Maybe some of you remember companies like Thinking Machines, MassPar. These were companies that were formed around trying to commercialize massively parallel processing technologies. It became a very difficult process to, let's say, create applications that business application users could actually use, let's say, outside of the laboratory. And so, a lot of those companies that started up in that area just eventually died. But, the thinking around massive computing or massively parallel computing didn't die, continued along, and has advanced to the point where it's really very well developed. We see lots of examples of it in, let's say, Hadoop clusters, for example. And particularly in the analytics applications, it's become sort of the bedrock of the big data movement. So, with that, I would like to pass it over to Nikita. Just let's say that the result of the confluence of those two forces is very high performance memory that scales to the size of entire databases by creating something that I think Nikita will refer to as a fabric. Is scalable and persistent, and can even manage data, and can ultimately support converged real-time analytics applications. So, Nikita Ivanov, I will turn it over to you.
All right, John, thank you. Good morning or good afternoon, as we say, depending who you're joining from. My name is Nikita Ivanov. I'm a founder and Chief Technology Officer of GridGain Systems. What I want to talk about is kind of give you the example of the technology that John just described and mentioned. And I want to start with conversation about evolution of memory computing. And I think most of us kind of instinctively understand what is in-memory computing, right? You put data in memory. We kind of all understand memory is a lot faster. As a matter of fact, it's between 5,000 times to 1,000,000 times faster than a spinning disk or even flash. So we kind of instinctively understand the benefits of in-memory computing, but it's always interesting to see in a historical perspective how it's evolved. In-memory computing really started as a caching technology in literally, late 70s, early 80s, when we started to get a certain amount of RAM available in the computer. And back then we were talking about 8-bit and maybe 16-bit CPUs in computers. So caching was very simple. You basically move the most frequently elements that you're accessing from a disk to RAM. And since you are frequently accessing those data elements, it's nice to have them close to application in RAM instead of going over the network and maybe potentially to a disk and maybe sometimes to a tape. So the caching was that. And from that point on, throughout 80s and 90s, the caching technology really has been advancing in spades. We rapidly came to distributed caching because we couldn't put enough RAM on a single computer. Again, we were talking about 16-bit or even 32-bit computers. You can only put a few gigabytes of RAM on each computer. And if you need more, you need to string together multiple computers and use their RAM as a one virtual pool of RAM, hence distributed caching. Once distributed caching took hold, companies started adding features to it, and that's how we evolved into the in-memory data grids, which essentially, or in-memory databases, which are essentially a distributed caching on steroids. We added transactions, we added a complex failover, load balancing, complex, sophisticated, high availability, and all those different concepts around the same idea. And on a time scale, we're kind of arriving to 2005, 2006, and kind of lost maybe less of a decade. And that's where it actually, in the last maybe 5 years, it literally kind of exploded after that. You probably heard something about in-memory. In-memory BI, in-memory database options, in-memory analytics, in-memory streaming, in-memory this, in-memory that. And it's kind of great that we got so much exposure about this technology, but it really complicated the marketplace. If you try to read about it, trying to find a vendor or something that works for a particular company or project, you'll be very confused. So at GridGain, our idea was to bring simplicity back. And that's, I think, what we've done. If you look on the slide on the top right corner, we have the little picture of our in-memory data fabric. And then in-memory data fabric essentially is this layer of software that you can slide in between your data sources, whatever they are, SQL, NoSQL, or Hadoop, and between your applications on top. And this layer of software will intelligently load data from disk and flash devices into the RAM of this layer and let your applications access and process this data right there on the RAM layer dramatically faster than it is possible with a disk or flash-based technology. So this is a little bit bigger picture, and as I mentioned to you, the in-memory data fabric is literally a layer of software. It's very important that it slides in between. Unlike pretty much any other product on the market, we do not require you to rip and replace your existing data sources. So if you're running your databases, if you're running analytics in Oracle, Microsoft SQL, DB2, or maybe using some NoSQL databases, Cassandra, Mongoose, HBase, or you're doing some Hadoop-based work, continue to use those data sources. The whole idea behind the GridGain data fabric is ability to slide in, do not disrupt any of your existing data sources, and just provide a performance and high scalability to your data. And, without going too much into details, the way we do it, if you look from a kind of a bird's eye view, we basically have a technology that intelligently brings data from disk into the RAM layer and lets your application through our APIs access and process that data in RAM, in memory, versus constantly going back and forth to disk. And that's coupled with a massively parallelized processing. That combination gives tremendous performance and scalability. Beyond just the performance and scalability, which is the key elements of what we deliver to our customers, our fabric provides, typical, high enterprise features. We have a bank-level security capabilities. Our software is used by one of the leading banks in the world. We have a complete audit trail of all the data operations and essentially all the necessary security features. We have a high-end features like, for example, data center replication. We have a sophisticated DevOps and management capabilities. We have an open source version of the software. As a matter of fact, GridGain is an enterprise version of the Apache-based software. And we obviously provide support and maintenance for this software. So let me talk about the three key features. Actually, I'm probably going to mention four of them that comprise the in-memory data fabric. One of them is a data grid. And one of the interesting aspects of the in-memory data fabric is that, well, remember I mentioned we brought the simplicity back from this kind of complex view of many different point solutions. One of the key trait of in-memory data fabric from GridGain is that we brought the capabilities, different capabilities like data grid, compute grid, streaming grid, all under the umbrella of the same fabric, the same API, unified configuration, the same learning curve. It's very convenient for the end users to use that. So data grid is one of those key components. Data grid essentially is technology to store parallelized storage of data across multiple computers in RAM. So think about this. You have a couple terabytes of data, you have dozens of computers. How do you store that data across all of those computers, and how do you transact? How do you process? How do you do the failover? How do you do load balancing? How do you do backups? All these different things that come with data processing is managed by data grids. And we have fairly unique capabilities there. We support multiple strategies. There is replication and partitioning the data across multiple computers. We hold the record on the performance of a fully ACID transactions on the memory across multiple computers. If you're familiar with transactions that, traditional transactions in SQL databases, we support exactly the same transactional behavior, both optimistic and pessimistic transactions in a variety of these isolation levels. We support full SQL if you need it. We also support key value access and multiple different patterns of that access, but we also support a standard SQL access to our data. The next piece of technology I want to talk about is a computational grid, basically just simply compute. It's kind of very nice to compare both data grid and the compute grid because, as I mentioned to you, data grid is all about a parallelized storage of data in memory, and the compute grid is all about parallelized processing. Although they look and sound familiar, they're pretty different because in one situation you're storing data and you want to basically partition this data across multiple computers. In a computational world, you're basically providing a parallelized computations. An idea behind a parallelization of computation is pretty simple. If you have a task that takes a long time to run on one computer, if you can split this task into multiple subtasks and let those subtasks run in parallel and then just aggregate results from them, if you have, n nodes, in ideal case, your overall task can be done n times faster. That's the basic, fundamental, facts behind the parallel processing. And naturally, devil's in detail. So we support a long list of different features to really facilitate this type of processing. Because you can imagine it's not trivial. If you want to do everything manually, it's going to be fairly exhausting task because you have to support, a different types of APIs like fork and join and MapReduce. You have to support in a multiple deployments mode. You have to be able to schedule those tasks, manage those tasks, understand the topology of a cluster, load balancing, failover, all those different aspects. And what compute grids really do for you, they simplify all of those aspects for you as a developer. You can just concentrate on an actual task in hand, whether you're trying to calculate or process on this cluster, and the rest of those kind of plumbing features that will be done automatically for you. So the combination of compute and data grids is a really powerful combination. And GridGain Data Fabric, in-memory data fabric, is about the only product in the market that combines them two. You don't have to purchase or try to integrate two different point solutions It's all right in the Fabric. It's all 3-defined API. It's very nice and simple to use. Yet another key feature of what the Fabric does is in-memory streaming. That's a fairly new concept and a fairly new use case that we kind of observed in the last couple of years. And although it may sound similar to data grid, but it's not. Data grid really deals with a finite set of data, just the same way as database typically deals with the data sets that are fairly finite and fairly understood. Streaming is a very different use case. Streaming is actually a type of data that constantly streams in, and there is never a beginning of that specifically. There is never specifically an end of it. It's just the data that's constantly streaming in. And the way we process streaming data is very differently. And it stems from the fact that there is no end to it. You could actually say, well, give me all stream for a, in current time, because, it streams constantly in. So the way you process streaming data is based on a sliding window. You're always processing basically on the last 2 minutes, last 2 days, last 50 trades, last 50 transactions, or whatever the window you define. And from this fact, stems that, you need to have very different APIs to do that. And we also have a full support for a complex event processing and streaming in our Fabric. So now you have essentially 3 areas that are completely covered by a memory data fabric. You can store and process data in parallel. You can run a high-performance computation or just a general parallelized computations. And you can also do a fairly sophisticated streaming and complex event processing, all in the same fabric without a need to basically go outside, learn different APIs, different configuration, different approaches. We also, as a fourth component, we also provide a kind of a plug-and-play acceleration for Hadoop. Multiple clients asked us a couple of years ago that, it's great you guys have all these capabilities, but we're using Hadoop. And is there any kind of way you can basically provide acceleration, in-memory acceleration for Hadoop without, needing to rewrite everything and migrate the data? Because for that, there's already a product called Spark. In Apache Spark, if you're willing to rewrite everything from scratch, and if you're willing to move your data away from Hadoop to a different system, you can use Apache Spark for that. But if you if you want to stay within Hadoop, what's the solution? And in the last year and a half, we developed fairly unique, in my opinion, probably the only solution in the market today that provides you a complete plug-and-play, zero-code change Hadoop acceleration without any need to re-put into place, rewrite, or move your data away. We probably could spend the entire presentation talking about this, but very quickly, it's based on a technology of in-memory file system that's fully compatible with HDFS, and a memory MapReduce implementation that's, again, fully compatible with the Hadoop one based on Yarn. It's the latest version of Hadoop. And essentially, when we've done that, when you provide in a memory file system that's fully compatible with HDFS, and if you couple that with a memory MapReduce implementation, you get a tremendous performance benefits. In the same time, since it's all plugged into the existing Hadoop infrastructure, it requires, as I mentioned, absolutely zero code rewrite, data movement, or anything else. As a matter of fact, you can literally just download the Apache Accelerator, the Hadoop Accelerator, install it along the side of your Hadoop, and within minutes, you can get anywhere from 2 to 5 to sometimes 100x performance, almost 2 orders of magnitude performance increase on certain types of payloads. We just recently run an example. I'll give you that. The simple pi calculation on the Hadoop cluster. The standard example that comes with Hadoop, whenever you download Hadoop, it comes with it. You can run with the Hadoop. You can run with a GridGain Hadoop Accelerator. You literally get out of the box about 20x performance, 20 times faster, without absolutely no code change, nothing to change at all. Just basically use a different type of plugin and software that we provide. It's a very exciting technology. There's a lot of Hadoop payloads that are right now kind of struggling with performance. People trying to put this into more kind of operational analytics and BI workflows, and the performance there is becoming paramount. and we have a pretty cool solution for that as well. Again, all part of our fabric, which is very, very cool. Just a couple of words. I mentioned that we have an open, basically GridGain is the enterprise version of Apache software product. It's an open source. Very simple model. We open core model. Major components available there, right? In open source, in memory data grid, compute grid, streaming in Hadoop, all available as an open source project. You can download for free, use it as much as you like. We also have an enterprise version, we call it GridGain Memory Data Fabric, that comes with a bunch of enterprise level features. And the philosophy here is very simple. If you want to have kind of mission critical deployment, you really need enterprise version because it comes with security, with network segmentation protection. It comes with rolling updates, so you don't have to bring down the cluster to make an update, to update the software, management and monitoring, and things like that. So you have a choice, and you have a freedom to use which version you like. And we'll basically talk about one more example, but I want to briefly get back to John.
Yeah, Nikita, thank you. Before I do that, though, I just have I'm a storage guy, so I have a couple of kind of storage-related questions, if you don't mind. I mean, one of the things that strikes me about this technology is that we're used to thinking of large RAID arrays as big persistent data stores, for applications and potentially other uses. But what I think you're talking about here is creating a memory fabric that in some ways acts like a persistent data store. Would you agree with that statement?
Yes, and even more so if you think about upcoming non-volatile RAM,
right,
which is already available. It's called NVDIMMs, non-volatile DIMMs. That will completely erase the difference between your disk and your RAM, because your RAM, what's the kind of perceived problem with the RAM today? You unplug from power, data is gone, right? That's what's called a random access memory. The new technology that we're actually working with Intel and Micron to be one of the first software middleware products supporting that. This new type of memory will be absolutely compatible with the current memory. It's going to be simple DDR3, DDR4 that you can plug into your computer. But the magic there, you unplug from the power, data doesn't get removed. It's still there. So next time you plug your computer in, it's still there. So that's already available. And in a year or two, we're going to see more and more capacity-based improvements in terms of what kind of DIMMs can shipped. And the operating systems guys and the motherboard producers have to basically work on some of the firmware issues. But that will completely revolutionize the way we think about storage.
I completely agree.
Intel is already calling the spinning disk a spinning rust, because essentially with NVDIMMs, the whole need for spinning disk, even for flash, will kind of becomes questionable. And there may be some economical points, but those are going to be quickly erased, in our today's society and technology. So in 2 or 3 years from now, we have the same conversation. We're not going to be asking these questions. In 2 or 3 years, the storage will be RAM.
So you have ways of protecting data as well as that is living.
Yes,
in
even today, we have customers with 5 nines of uptime. It's very simple to do with our software. We can back up the same data in multiple nodes. We can even back up data on the disk. If you're willing to take a little bit of a performance hit, we can back up your data in RAM, onto the flash or onto the disk. So it's up to the user to decide which kind of knobs to turn, which balance he would accept in terms of performance and persistence of its data.
Okay, good. So let's go on to some business use cases and then get to Q&A. I always think when I think of business use cases for today's sort of big data applications, I think of this statement: if we could harness all our data, we would be a much stronger business. This came from a CompTIA survey where 2/3 of business executives were asked to either agree or, disagree, agree, strongly agree with that statement, and they found is that 2/3 of business executives either agreed or strongly agreed with that statement. So from there, let's talk about some of the things that people are doing today that are examples of converging different data stores or different data sources in real time to produce new types of information that push their business forward. And one of the things that I think a lot of people are becoming familiar with now is the use of sentiment analysis, particularly in retail, and this is the ability to converge, let's say, Twitter feeds and Facebook feeds with a customer database. And so you can potentially, broadcast to, or let's say, selectively deliver, particular buying messages to a particular customer, let's say, on a retail floor based on, let's say, where they are spatially on the retail floor. And an understanding of that, and an understanding of what the particular customer's likes, dislikes are based on understanding data from Twitter or Facebook or other social media sources. And so that kind of analysis is typically now referred to as sentiment analysis, and the retail industry has become very interested in doing these kinds of things. And what I've seen is that success with, let's say, doing one type of real-time analytics leads to an understanding, first of all, of how it works, and second of all, very creative thought process about how it could be applied in other places. So you could use it to optimize inventory in real time, or enhance customer satisfaction in other ways, optimize pricing and supply efficiency. You could do real-time analysis of supply chain. So if something, for example, is trending on Twitter, and all of a sudden you're seeing a spike in demand for a particular product as a result, you can be more proactive in trying to predict what other spikes in Twitter feeds might also do to sales of particular products, and you can make sure the supply chain is ready for that demand. So that's one example, and I think a lot of people are now becoming familiar with the way that credit card fraud detection is done in real time now in financial services. So it's one thing to know that if after the fact that a fraudulent transaction has occurred, and maybe you could backtrack and find the source and do something about it. But what you'd really rather do is stop it in real time, so the transaction never occurs. And that's what financial services companies that deal with credit cards are now trying to do as well. But Nikita, let me pass it over to you to talk about some of your customer applications.
Yes, just a quick, just kind of data point. GridGain is used in a lot of different projects and deployments. Our software starts literally about 10 seconds around the globe. But just a couple of basically what we observed over the years, some of the clusters of our users is definitely in financial services and things like automated trading systems, whether it's a real-time analysis, positions, option pricing, risks, and whatnot. Definitely low latency trading, and it's a very generic term, but a variety of different applications there as well, based on GridGain technology. In the financial service in general, fraud protection and detection is something John mentioned already. Modeling, insurance, things that require a substantial computational power and a time sensitive, which probably today defines almost everything that financial service companies do. We have customers in production in those areas. Big data analytics in general is definitely, without any surprises, is a growing area for us. Just very different types of application, from any kind of real-time analysis and inventory and purchasing, operational, actionable BI. Those terms used quite often, and we have customers and users in these areas. But also, interestingly enough, we have, a substantial following in things like online gaming, whether it's, back end of some of the, Sony massively multiplayer games that use GridGain on the back end to a merchant platforms for in-app purchases for mobile games and things of that nature. Bioinformatics, almost everything that happens in bioinformatics and drug discovery requires a substantial computational power and large data sets. And that's a perfect recipe for where and how GridGain can be used. Some of the companies we work with, like companies like Expertise, for example, a company called ChronoTrack. Let me just put this example because we haven't talked about it. ChronoTrack is an interesting company. They do a sporting events management. So basically, your marathons, for example, like New York's marathon, Boston marathon, and they do not only a registration part, they also do basically tracking everybody who's participating in the marathon, wearing RFD tag, and when they go through gates, the RFD tag communicates with the system. And naturally, when you have thousands of people and hundreds of events around the globe, that's a massive amount of streaming data that come into the system. It's all based in GridGain. Things like CyberDesk. It's a small startup, but basically it's a very analogous to Snapshot. It's a time disappearing text and messages. They use us as well. eTherapeutics is one of those companies in the biotech area from UK that does the drug discovery and pretty sophisticated stuff, all based in GridGain as well. So GridGain specifically, and then memory technology in general, used in very different aspects, in very different types of payloads, in very different market segments even today. I basically want to leave you with this slide because it may be kind of, not very sexy, maybe boring, but it's a very telling example. About a year and a half ago, we won a pretty big deal with one largest bank in Europe. I think like number 3 bank in Europe. It was a very typical, kind of banking application. They were looking for a kind of leverage risk reporting on online trading. Essentially, all kind of risk analytics as we categorize them. So there was a big RFP, and there was many vendors, and then we won it. But what really shocked folks at Sberbank was the sheer number that, in terms of performance, that we delivered. Think about this number. We delivered a 1 billion with a B transactions per second. I'm talking about a fully asset financial transactions on just 10 commodity Dell blades. We're overall with 1 terabyte RAM across all of them. This 10 commodity blades with a terabyte RAM cost today around $25K. Now again, let it sink in your mind. Think about these numbers. A 1 billion with a B, fully asset transactions per second on $25K of hardware. That's the numbers like this. I call it an absolute game changer. They were actually, believe me, those guys in the bank, they retested like 10 times because they could not believe the numbers. They flew us to the Moscow headquarters to actually retest it again and again. We did it for them. These numbers basically were a complete, science fiction, literally a decade ago. Even today, if you take an Oracle database today, and you put it on the most tricked out Exalytics Exadata boxes that cost you millions of dollars, you may get anywhere between maybe 15 to 30 million transactions per second. And you're talking about one of the most complex setups in Oracle you can buy, as you can imagine, the price tag for it. Here, you getting a billion transactions a second, running on literally commodity level hardware. That's a game changer. And that's one example I want you to all kind of remember when you think about a memory company. What can it do for you? It really not just about marginal improvements in performance. It's about actually a dramatic qualitative change in what we can actually do in our businesses with this level of performance. John, back to you.
Yeah, thank you. So at this point, let me turn it over to Dane to moderate the Q&A. I've got, we've got about 10 minutes left, it looks like. Dane, do you have some questions queued up there?
Yeah, we do have a few questions here, and let me go ahead and jump into these. It looks like most of these will probably be for Nikita, because they do sort of seem to, pivot around the application. So let me run this first one by you, Nikita, and here's the question. If I have some data sets on Hadoop/Hive, so when I query it for the first time using HQL, does the data get loaded into the grid that first time, and the next call will be served by the grid, right? In other words, first call to disk, next call to grid. Does that question make sense to you, Nikita?
Yes, and by default, that's absolutely true. You can also preload those data sets into the RAM yourself. We provide you a very nice UI tool where you can basically browse the file system. If you know you're going to be working with this particular folder or set of files, just mark them up or just load them up into just literally copy from HDFS to GGFS, which is our in-memory file system. Just copy those files manually if you like it, and even on the first call to Hive, you're going to basically read them from RAM. It obviously makes sense, for example, for index files to be in RAM if you possibly can. But even if you don't do that, we will intelligently understand what is it actually you're accessing, and we're going to move it up to the RAM so that for the subsequent calls will be a lot quicker.
Great, thanks, Nikita. Now, and this one is also, looks like for Nikita, but John, feel free to chime in if you have anything to add.
Sure.
Here's the question, and this is not surprising given all the security issues we see out there these days. The question is, can you expand a bit on the security features that come with the commercial version versus the open source? And Nikita, I think that's probably best for you.
Yeah.
Yes. As far as security features, they're part of our enterprise version. If you guys know anything about security, the assumptions that bad guys are already in. Almost everybody gave up on kind of putting barriers in front of the bad people getting in. So the assumptions every security officers have around the globe today that people are already inside. It's a question: how do we track? How do we minimize the damage? How do we know what's happening? And from perspective of GridGain as the middleware software, the only thing we can do beyond the obvious encryption and whatnot that we support, like SSL, is the full audit trail of data changes. And that's what we're delivering on enterprise version. So you can keep data in RAM and have an entire audit trail of who changed when and what data. What was data before the change? What was data after the change? And I cannot name the names, but we work with almost the #1 bank in the world today. And a lot of the requirements, a lot of the functionality that we have in the product was driven by their requirements. Believe me, if we're good for them, which we are, we're good for 99% of other installations around the globe. It's a very stringent requirements. It's a lot of complex processes we had to go through to really satisfy those requirements. So we're pretty confident about our security features.
Yeah, and let me just say that I think there's something of a prevailing sentiment out there that open source is sort of inherently insecure versus commercial. And I think it's a bit unfair. I mean, I know it took Hadoop a long time to develop the kinds of security features that the enterprise wanted to see. But on the other hand, there are a number of open source projects now that really started out as commercial projects or applications, and they had security features built in when they started. So I mean, I'm not sure that that tag is really justified.
Great. Okay, thanks, guys. Now here's another one, and I hope it's not too generic of a question, but the question is, I would like to know more about video data analysis /analytics. Can you address that, Nikita?
It is kind of
Or is that
generic.
Yeah,
But I can tell you
I mean, I can take a shot at it too, Nikita, if you want. But go ahead.
Yeah. Just a quick note. We work with Nielsen rating agency, and one of the projects we work with them. Actually, we had a couple of projects in the different companies, or very much the same nature. Is analyzing the audio captions and basically understanding what's happening in the video in a video line timeline, and that's a traditional high performance task because you're analyzing video, you're analyzing audio, trying to sync it up, trying to understand what's happening. It's a speech recognition, it's NLP type processing. So GridGain is absolutely usable, and actually we have pretty cool support for some of the features that those engineers really ask us to have. So yes, we use there, but it's just a one use case for us that we support as well.
Yeah, I would say that these video applications are very data intensive, and you got a lot of data to try to deal with if you're going to do something in real time. And again, I think this is one of the things that in memory technology that's scalable can really help with. But you don't need that high resolution an image to be able to do some pretty interesting things. For example, in Las Vegas, the gaming industry uses video analytics in real time, and because what they found is that there are players at, let's say, a backgammon table or a craps table can make certain motions that are indicative of suspicious activity, let's say. And those motions are fairly common, they're repeatable, and so if a system sort of picks those up, they can identify what table and potentially who, and sort of keep an eye out. Palming cards and things like that. You have sort of certain body motions in order to do that, and so you can pick those up in a fairly low res image. And that's just one example. There are all kinds of other ways to use video in real time streaming applications, and the technology is really advancing.
Great. Thanks, guys. Now, we only have about 2 minutes left. I'm going to try to squeeze in this one last question here, but bear the time in mind. So here's the question. Can you expand on the claim that there's no need for a rip and replace? Surely there are changes required to our existing structures. And I know that's a kind of an open question, but Nikita, can you address that in 1 minute?
Yes. Probably in comparison, it's pretty cool. It's pretty easy to understand. Think about your typical in-memory database. Let's say you're in Oracle, and I don't know, you want to go with MemSQL or VaultDB. Well, guess what? You have to rip and replace Oracle. You have to remove Oracle from your system, or you have to move some of the data from Oracle into the VaultDB. And in typical organization, that's like a 12 to 18 months project. I mean, if you work in any size of organization, try to go to your IT organization and say, you know what? Let's get rid of Oracle and replace with X. And I can almost predict the reaction that will happen. So that's what we're talking about, because in a GridGain scenario, or systems like GridGain, we specifically work on top of the existing data sources. So all cases, you do not have to touch anything on your database, which is critical for enterprises. The last thing you want to do is to go to your IT database departments and say, you know what, we have to install new triggers, or we have to install new software or new version of that. That's a no-go. What we're saying basically, don't touch it. Literally, we work through GDBC driver, that's it. What you need to make some changes on is your application layer, because naturally you have to go now through a GridGain, not directly through GDBC or anything else, or something like that. So these changes can be they can be trivial, they can be not. Typically, probably typically is the wrong word here, but what I've seen anywhere from a day to several months of work. And typically, like for example, we do our POCs, proof of concept for customers, majority of our proof of concepts are 2 or 3 days projects. So within the 2 or 3 days of integration work, we can prove out the value. It may take longer now to put it in production and actually, deploy it to an entire system. That's a different story. It may take you weeks, sometimes can take you months. But typically within a few days, you can prove out the value, you can install something and, get it working properly, which is completely not the case with traditional memory databases that require a complete rip-into-place data transition and everything else. Hope I answered this question, but it's a pretty loaded question. It's a lot easier to answer that on a specific example.
Yeah, that was a big question, so appreciate your handling that very quickly. And we are out of time, so I want to thank John and Nikita for all that great information. I hope everyone got a lot out of today's presentation. As we sign off, I did want to remind you about the attachments that I mentioned earlier under the Attachments tab, and also if you'd be so kind to rate the webinar and or leave any comments in the questions area. That will really help us to improve material for future webinars. With that, everyone, have a great rest of the day, and thanks again for attending.